All right, welcome back. We're on to 4.4, raising fractions to powers. And once again, this is a very short and fairly simple lesson. I think you guys are going to start to love fractions because these lessons are just so short. So it's exponents along with fractions, two topics that maybe you might not love, but when you put them together, it's actually not that hard. So we'll just jump right into this first one right here. There's no like intro to this, just right into the first problem. We'll talk about exponents in general. So what does it mean when we say, let's say 4 to the third power? Well, that's really just saying 4 times 4 times 4, right? It's multiplying 4 3 times. And it's no different with fractions. So this is 2/5 to the third power, or 2/5 cubed. So it'll be 2/5 times 2/5 times 2/5. And now we know how to multiply fractions now. We know how easy it is to multiply fractions. And we've only multiplied 2 fractions. Can you do the same thing with 3? I mean, of course. If you wanted to even show that one step at a time, if you weren't sure, you know that this fraction, this right here, 2/5 times 2/5 would be 2 times 2 over 5 times 5, which would be 4 over 25. Right? And that's this part. And then we are still left with our times 2 over 5. And now we know we could just do it again. We didn't need to do that in 2 steps. We can do it in 1 step. But this is going to be 8 over 125. To do that again, we had 2/5. I'll try to write quickly. Forgive my sloppiness. Times 2/5. All right, so we know that that is going to be 2 times 2 times 2, and 5 times 5 times 5. So that will actually equal, look at this, 2 cubed over 5 cubed. And so 2/5 cubed is equal to 2 cubed over 5 cubed. So this this exponent here sort of, it's not called distribute, but it sort of like distributes there, right? So it goes to the 2 and it goes to the 5, both the numerator and the denominator. So let b be a non-zero, let b be non-zero, and let n be a positive integer. Explain why. That is kind of like we just showed. So let's do the same thing, but I mentioned maybe a couple of chapters ago, let's get used to working with variables and not always working with numbers. So let's go ahead and do the same thing, but with these variables. So we have a over b times, well, we're going to do it n number of times. So we'll do a over b times a over b. We don't know what n is. We'll do dot, 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 however many n times is. And a over b times a over b, right? And all this is going to happen n times. And so what we're going to get out of here is a times a times a times a times a times a n times. So we're going to multiply a n number of times, even if that is 1 time. Sometimes it could even be negative, it doesn't really matter. And same with b. b times b times b times b. How many times? N times. So it would be b to the n. So that's why a over b to the n is equal to a to the n over b to the n. All right, so now let's evaluate 5 over 7 to the negative 1. Well, if you remember negative exponents, so something, let's say 4 to the negative 1 is the same thing as saying 4, actually no, let's do 4 to the negative 2, just to show. 4 to the negative 2 is the same thing as saying 1 over 4 squared. Right, we take the reciprocal and then have the positive exponent there in the denominator. So we'll do the same thing here. We'll say 5 over 7 to the negative first would be the same thing as 1 over 5 over 7 to the 1. And so now we already know what 1 over 5 over 7 is now. That is just going to be 7 over 5. We'll just flip it over like we did in the last section. So 5 over 7 to the negative 1 is going to be the reciprocal, going to be 7 over 5. Okay, so now let's try it this way. Let's do 1 over 4 over 3 cubed. Same thing as if we were doing something like this. We just have a fraction. Well, we know that if we cube this whole fraction, then it's going to leave us with 1 over 4 cubed over 3 cubed. Well, we know when we have the reciprocal here, when we have like a fraction in a denominator, all we do is just flip this fraction over. So it's going to end up being 3 cubed over 4 cubed. Or if you want to multiply that out, that would be 27 over 64. All right. So now we can see, and we could have already assumed this, when we have a negative exponent, we're going to be flipping the fraction and then applying the exponent. So let's go through and do that. So a over b to the negative end is going to be 1 over a over b to the positive end. Okay. And we know that a over b to the positive end is going to be a to the n over b to the n. And the reciprocal of a fraction is just going to be the flipped over fraction, b to the n. That's not a very good exponent there, but you get the idea, over a to the n. All right. I think this might be the last problem here. Okay, this one's a little bit harder though. So where do we begin with this? All right, well, first of all, what do we have that's similar here? I see 21 over 31 here, 21 over 31 there. Maybe we could do something with that. So let's go ahead and get rid of this. We know that if we have something like 4 times 2 over 5, we can break that up and say 4 over 5 times 2. We know we can do that. So let's do that here. So we have 21 over 31 to the 5th over 21 over 31 squared times this part, 31 over 21 cubed. Now, why is it written like this with a slash instead of on top of each other? That's just to make it simple to know that it's a fraction inside of a fraction, rather than, because if you have something like, if I write it something like this, 1 over 2 over 5. Now, is this 1/2 over 5, or is this 1 over 2/5? Sometimes it's not super obvious. It looks like this line might be a little bit smaller than this one. I don't know, it's kind of hard to tell, right? So you don't know if this is 1/2 over 5 or if it's 1 over 2/5, and it makes a difference. Those are two different problems there. So just to make it really clear, sometimes you'll see it written like this to know where, where the fractions are separated. So anyways, where were we? So we're here now. So remember, fraction is just division. So this is the same thing as saying 21 over 31 fifths divided by 21 over 31 squared times 31 over 21 cubed. Okay, so now we know our exponent rules. If you remember back from chapter 2, if we are dividing powers with the same base, we have 21 over 31, 21 over 31, they have the same base, so we can subtract these powers here, these exponents. So then we're left with 21 over 31. We have 5 minus 2, that's going to be 3, times 31 over 21 cubed. Okay, well, there's a few different ways that we could do this now. So we could extract out this exponent. We've done that before. So this would be the same thing as saying 21 over 31 times 31 over 21 cubed. That's a pretty good way to start. And now what you see here is, what we could do is we can combine these as a 21 times 31 over 31 times 21. And we might recognize that we could move things around. Remember the shortcuts we talked about in the last section? This could end up being 21 over 21 and then 31 over 31. And so it'd be 1 times 1, which would be 1, which it is 1. Another thing to recognize is that what is the reciprocal of 21 over 31? The reciprocal of 21 over 31 is 31 over 21. These are reciprocals, which means you multiply them together and the product is going to be 1. So either way, you're going to get 1 cubed, which is just going to be 1. All right, and that's it for 4.4. So go ahead and try these exercises. And we're just about halfway through this chapter. If you were to look at the Art of Problem Solving course list, you would see that pre-algebra is actually broken up into A and B, pre-algebra A and pre-algebra B. Pre-algebra A ends after chapter 7, which means we're about halfway through pre-algebra A, if you're going to go with the A and B. I'm going to keep on going and do the entire book. I'm going to go all the way through chapter 15. But, if you're following pre-algebra A and pre-algebra B, we are halfway through. So I'll see you next time.